There's really two types of predictions you can make. You can make what's called a classification prediction, which is predicting an outcome, A, B, or C, or yes or no, or true or false, or which type of car do I drive, a pickup, a sedan, or a compact car. The other kind of prediction is a regression, and that's predicting a value. So a number that could be a dollar amount, it could be a time frame, it could be a measurement of some sort. So it's a continuous number that you're predicting. In both cases, you get with that prediction a likelihood, or you can, depending on the algorithm, get a likelihood that the prediction is correct. And so together, the actual prediction plus that likelihood are very useful information to apply to your business problem. You don't predict directly with like clustering algorithms and anomaly detection algorithms, but they can support the process where a predictive model might be useful. In some situations, if you don't have enough volume or quality historical data, sometimes you can't start with predictive model. And in those cases, an anomaly detection model can be useful. So for example, maybe you have a business process where money is exchanged between third parties and fraud and abuse are a problem. And over time, you've been finding fraud and dealing with it, but you haven't recorded it systematically in your database as it's occurred. And so I don't have this history that I can use to say, oh, here's all this activity that happened in the last year, and these were the ones that were fraud, and these are the ones that were not. Absent that, you would use anomaly detection to help you find the anomalies in your data that make things look suspicious. Then you investigate the ones that are suspicious, you find which are fraud, and you label them. And so over time, you've built up now what's called labeled data, the data that you'd need to make a predictive model. A lot of times you need to start with anomaly and then you move to predictive. But it really depends on the use case and the quality and volume of your data. Clustering models can be helpful, not to predict directly, but to help you understand a population. Maybe it's a population of customers, maybe it's a population of employees or a population of vendors, but you want to segment those vendors or customers into groups based on dimensions that you think as a business person will have meaning in how you deal with those customers. So for example, I might use indicators about a customer's value. How much have they spend? What's their income levels? Information about their demographics. I might also have information about their risk. Are these people with a high FICO score or a low FICO score or things like that? And what the clustering model does that humans can't do very easily themselves is take all those important indicators that you feel help describe your customer base thoroughly and build clusters that consider all those at once. And it's that multidimensional aspect of clustering that gives you then segments of customers that are similar, and the degree of their similarity is also part of those models. And with that information, now you can do some associations. You can say, well, if you're in my segment of young and financially beginners, low bank account levels or low income or whatever, I'm going to treat you differently than this other group of high income customers that I've got. So your marketing strategy then can be tailored. And now I can use those segments to drive different marketing campaigns more easily, rather than each time going out and saying, oh, okay, well, let's find out who these customers are every time you run a campaign. It's not a prediction, but it is an association saying, well, I know the nature of this subset of my customers. I'm going to treat them differently.